So I've said already at one point, so we're covering measures of angles today, chapter 1.5. And I believe I've said already that we can't really assume anything just because it looks like it doesn't mean it is. And this here is one of the, I would say, kind of greatest examples of that. Let's see here. So I'm going to draw this straight line here. And we can use a protractor to measure an angle. So right up here, so right here is 90 degrees. And right there is 91 degrees. Move that to the side. So if we drew a straight line, or if I drew a straight line here, I mean, the slight difference between those two is insignificant, yes? So trying to tell the difference between 1 degree, between 89 and 90 degrees is almost impossible. That line would just be tilted just barely. Do y'all see that there? Yeah, no, that's the magical properties of this thing here. And no matter what I do, it always will, it's just a tool in the program. Is 89 and 90 degrees are so close, it's hard to just be able to judge based off what we see. So we have this here. Now, how many of y'all have used a protractor? Yes? If we start on this at 0, we line it up and count on the inside. If we're coming from this direction, we count on the outside, yes? And that's how we use to measure angles. Now, an angle is a set of points consisting of 2 different rays. So 2 different rays combine to make an angle. It's 2 rays that share a common endpoint and whose sides are not the same. So the vertex is the endpoint of the 2 rays, and the sides are the 2 rays. So obviously that jumps, so I'm going to just say this one more time. So we can name it using the 3 letters. We can name it using the vertex if it's the only angle there. So we can call this vertex angle A. Or we can use the number inside, so angle 1. So these are different ways to name it here. Questions on this here? We good with this here? Okay. Interior of an angle and exterior of an angle. Anybody have a guess at what the interior of an angle would be? All the points in between the 2 rays. Between the 2 sides of an angle. Exterior, all the points. Outside the angle. Interior angle, all the points inside. Exterior, all the points outside. Pretty much exactly like it sounds. I think I drew a little angle there for you. So you can almost inside the 2 lines, you can write interior and out, pretty much outside you can write exterior. Interior, inside, exterior, outside. So not too bad there. So, naming angles. Naming angles is going to be the first thing we're really looking at. A lighthouse keeper measures the angles formed by the lighthouse at point M and 3 boats. Name 3 angles shown in the diagram. Well, let's just go on and name them all. So what's one angle that we have here? JMK, because I heard a few. I just couldn't hear them all at once. JMK. We also have JM what? Well, That's it for J, isn't it? JMK, JML. Then what can we do? K, KMJ, angle LMK, I think I heard, and angle LMJ, yes? We have that one, this one, this one. Yep, that's all of them. Can I name this angle M? Why not? We've got two angles. We actually got three. Because we have this one, and then the big one. So since there's more than one angle, I cannot name it based off its vertex. Because we can only use the vertex if there is one angle. And the reason I do that is because if I try to name it angle M, do we know which one of those we're talking about? No. So we can't use it. Now, if they'd have had numbers inside here, we could have used those to name, if this had marker. If we had 1 and 2, then I can name it angle 1 and angle 2. But since it doesn't have the numbers there, we can't use those. Questions on any of this here? Naming angles pretty easy. Do we need to see another example of naming angles? No? So, I mean, this here is going to be angle PQR, angle RQP, angle Q. Here we have angle XYZ, angle ZX, angle 1, angle Y. Angle 2, angle E, angle DEF, angle FCD. So you don't have to have all those down in your notes. I'm just listing them up there, so if you want to go back and re-see it and check on them, you can. So since we're good with these here, I'm going to go on and move on to the protractor postulate. Protractor postulate. Consider OB a point on A on one side of line OB. The ray OA, the ray of the form OA can be matched to 1 with the real numbers from 0 to 180. The measure of angle OAB, which can be written as measure M, so our little m, again, talking about the measure, angle OAB is equal to the absolute value of the difference between the real number matched with ray OA and OB on a protractor. All we're saying is that when I put a protractor down, the difference, so whatever number this line is at and this line is at will be the measure of this. Okay? Now if it works out, one of those is at 0. OB, ray OB is at 0, yes? So I'm going to start here, and I would start on the inside and go 10, 20, 30, 40, 50, 60, 70, 80, all the way up to 140, yes? And that's it. If it worked out to be these two lines, what am I going? I went over to 10, 20, 30, 40, 50, yes? Is there actually 10, 20, 30, 40, 50 between them? No, I'm just counting the difference, yes? This one's at 90, this one's at 140. 40 minus 90 is 50, yes? That's what it's talking about, the measure, those two values that they have. We can subtract from them, okay? That's all that postulate says. There are 5 types of angles. Anybody have a guess of what this one is? Acute angle. We have all this up, but really the angle is between 0 and 90. Our next one is a angle whose measure is. Then we have an measure is greater than 90 and less than 180, and then we have a straight angle, which is measure is 180. Can I have an angle that is greater than 180 degrees? Yes. What would we call it? The angle that is slightly greater than 180. Well, we can go beyond 360, but not in the planes that we will talk about in here. So an angle like this here. So this is greater than 180, yes? So what would we call it? Obtuse. We call it obtuse. Because this side here is greater than 180, yes? This side over here is greater than 90, yes? So this here is Let's look at a cube. This whole angle here, is that greater than 180? As 180 would be a straight line, yes? So over here would be 180, so we're beyond 180. But what do we call it? We call it an acute angle, yes? The angles we focus on, a lot of the times with naming them, is not the one that's bigger than 180. Because once we go past 180, we're not looking at that one, we're looking at the other side. Does that make sense? So we're not looking at this angle anymore, we're looking at this one down here. Y'all see this here? So when we talk about the measure of the angles, we're really focused on the ones that are equal to or less than 180. If it ever goes beyond 180, we're not looking at that one anymore, we're looking at the other part of it. Find the measure of each angle, then classify it. Now, at some points I gave out protractors and we measured angles, but we're not going to worry about that here because they gave us a nice little picture here. So GHK, GHK. So this is at 0, yes? Would I use the numbers on the inside of the protractor here or the numbers on the outside? Outside, because it started at 0. So 10, 20, 30, 40, 50, 60. So, yes. So the measure of angle GHK is equal to 125 degrees. And that little circle that we put up there is going to be our degree marker. It tells us it's 125 degrees. Questions on the first one? We go with the first one? Yes? The measure of angle JHL. Yes? So JHL is straight up, so that is 90 degrees. LHK. So these here aren't at exact points, are they? Now you can pick inside or outside, but so for what I'm going to show you, I'm going to pick the inside arc, the inside numbers, and HL is at, HK is at 55, yes? And I'm going to subtract them. 8, 10, so 5, I get 35 degrees. Now, again, this is going back to the protractor postulate, okay? Because the protractor postulate was saying where they lie on the real number system. So for those two angles, for those two lines, we take those numbers and take the absolute value of their difference, yes? The reason they say the absolute value is if I decided to do this, that would give me negative 35, yes? What's the absolute value of negative 35? So we get the same number, yes? If this was a real world problem, like you were really trying to do this, I would not leave it like that. I would actually turn that protractor and zero up one of these two here to measure it. Yes? What's the other way we can do? Well, there's 10, there's 20, there's 30, and I can count the little ones, which gives me 5, so it's 35. That's it there. Questions on this here? We pretty comfortable with this here? We good, Eric? You all need to see more examples of this here. If you do, we can go over these. If not, we can move on. You good? Yes? It might be hard to see on your paper, but if you look really closely, do you see those little red arcs or the little double line things? I mentioned this, I believe, in 1.3, one of the videos. I talked about the little hash marks on a line, where if you have those little kind of small marks on a line, it signifies they are congruent. That's the way we signify with lines. With angles, we use these kind of little arc lines in the middle of them. So whichever lines has the same number are congruent. That's the way to say the two angles are congruent. Okay? So if two angles are congruent, it means they have the same measure. They have the same measure of rotation. Rotation, how far they open. Identify the congruent angles labeled in the quilt design. Well, one of them, because it's kind of hard to see, is EFG is congruent to angle ADC. I think that's a C right there. We can't, it's hard to see. And then we have one more. Ready? We can see it now? And the other one is at FGH is congruent to angle ABC. Now, is this the only way we can write these statements? No. Because how many different ways can we name each one of those angles? 3 different ways, yes? Because at EFG, it is one angle, yes? At any of these, it's only one. So I can name it based off the vertex, and then using those 3 letters in 2 different ways, yes? So each one of those I can name 3 different ways for each one. So if this setup I have 3 here, the second way I can do this, I would have 3. Each one of those I'd have 3. I'd have 9 different ways I can name each one of those. There's 3 and 3, so we can match them up 9 different ways. But it's the only thing I'd make sure, especially I think the homework will give you choices to pick from. You just got to make sure it's naming the correct angles. Both are naming the correct angles. If ADC is 140, what is EFG? 140. Because they are congruent, they have the same measure. Questions on this here? No? Pretty easy so far? Angle addition postulate. I'm going to turn the lights back on, you'll all be blinded. Okay. Looking at this here, what can you guys guess the angle addition postulate is? If P is in the interior of RST, then the measure of RST is equal to the sum of the measure of angle RSP and PST. If these two make a whole, this plus this equals the whole thing. That's it. The measure of the 2 parts equals the whole. That's the angle addition postulate. But again, in mathematics, we want to prove something's true or have a postulate that states it's true so that we can use it. We want to show that it works every single time. Okay? And a postulate is something that works, and we really don't have to prove it. So, we good with this here? So we're jumping right into it. Yep. So normally I think I have some others. There are other examples, and I skipped straight over them. I'll do this here. You guys can just watch this. There's no real reason to write this down. If this is 70 and this is 60, what's the whole thing? 130. We just added 70 and 60 together to equal the whole, yes? If I told you, let's erase that. If I told you the whole thing was 150 and this measure was 50, what's the other angle? 100, yes? That's partially the reason I didn't include them, because we get this. Now, when we look at this here, we said that given that the measure of LKN is 145, what is LKN? The whole thing, yes? And according to our postulate, the measure of angle LKN is equal to the measure of LKM plus the measure of angle MKN. Yes? The whole is equal to the sum of the parts. The whole angle is equal to each of the two different angles added together. Yes? So what's the whole angle? I'm going to put it here. What's the measure of LKM? It doesn't have a number, does it? It's 2x plus 10, isn't it? That's what it's pointing at. So we'll put that down, 2x plus 10. What's the other one? 4x. Because these two angles added together will equal what? Yes. So when we looked at it at the start, 90 and 89, did they look similar? Yes? Now, it was easy to tell when I had them sitting pretty much next to each other, but when we take one away, it's very hard to tell the difference between a degree. So one of the biggest things in mathematics, or what you'll learn in geometry, is just because it looks like it is, doesn't mean it is. Okay? A lot of the tests will do this. So we have X in here, kind of a triangle. This is whatever it is. This is whatever it is. And you work it out and you find X is, does that look like 100 degrees? No, the pictures are going to lie, 100%. It looks like it's an acute angle. It looks like it's less than 90, but it works out it's not. There's a reason for it. I made the test. I made all of them. I drew them by hand. And I'm like, okay, we're doing a triangle. I drew a triangle. Then I set it up, and it worked out that X was greater than 100. It was equal to 100. Does that make sense? I made the picture, then did the problem. But the math will still hold true. The pictures won't always look it. And another reason they make it so the pictures don't always look what they actually are, they make them look different than what they are, is so that you can't grab a compass, plot it down, up, I got the measure, because it defeats the purpose. Okay? So we'll go on and work out. It might be 90. I have a feeling it's probably going to be 88 or 89. It's going to be close. So that was our geometry step, yes? Welcome back to Algebra 1. We're going to combine like terms. So what are our like terms? 2x and, which is? 10 minus 3 is? Now what do we do? And divide by 6. Was everybody able to keep up with that? Yes? Yes? The guys haven't been nitpicks about it, but laptops either, you can have them open, but they can't be in front of you. I prefer them. I'd be using this. You also have them up there. Yeah. It's, let me pause this. So looking at this here, so x equals 23, does that give us what we wanted? Is that the answer? Well, we want to know the measure of the angles, yes? So we just have to plug it back in, yes? Which one do y'all want to plug it into? 4x minus 3 or 2x plus 10? We will. So let's do 4x minus 3 first. So it would be 4 times 23 minus 3. At this point here, you can type that whole thing into a calculator. 4 parentheses 23 minus 3. Well, 4 times 23, well, 4 times 3 is 2, carry the 1. 4 times 2 is 8, plus 1 is 9. I had a feeling it was going to be 89 degrees. I'm going to erase this here so I have some room. So we found that the measure of angle NKM, or MKN, is 89 degrees. Now, there's two ways we can go about finding the other angle. One of them is plugging it into 2x plus 10. But what did we say the whole angle was? 45. And we know one of them is 89. I can do what? 145 minus to get the other answer. Or if we do 2 times 23 plus 10 would also get it. So 2 times 23 would be 46, plus 10 is 'and those are our two angles. Okay, good. I started recording again. So any questions on this here? We good with this here? Yes? Where we at? Okay. Do we need to see another example of this? No, we're good with this here? Yes? Okay. If we're good with this here, we'll move on, because this here, what would we set it equal to? I just want to make sure we have that. 180, because it's a straight line. So then we'd add them together, solve for x, and plug it back in. What would we do for this one here? They would be set equal to 90, yes? It's a little red box. 90. It's a 90-degree marker. Now, this here, using a bisector. So bisector means to cut in half. So when we see bisector of any kind, it's cutting it in half. QS bisects the angle, and the measure of this one angle is 24. PQR, the whole angle, would be what? 48. Because that one's 24, it means the other one is 24. So the measure of angle PQR should be 48 degrees, because it's half, so we can double it to get the whole. That's not too bad, is it? Questions on this here? This one here, they told us that AVC is 158. So what would be the measure of AVB? So the whole thing is 158. If it bisects, it cuts it in half. So what would I do with 158? We divide it by 2, because it cut it in half. So both parts would be 79 degrees. Do you all agree with that? Questions on this here? No? We good with this here? I'm moving at a decent pace because I feel like most of y'all are getting this. We're moving. Yes? I'm not going to dwell on something if it makes sense to y'all, okay? If it doesn't, please say something. Please say something. And that's the end of your notes, yes? I added 2 more up here. And it's dealing with bisectors. So y'all can look at this and see what it is. Because Desiree, we didn't cover this in geometry when you took it. I literally added it 10 minutes ago, or whenever before this hour started. It's talking about bisectors, yes? So if this line bisects these angles here, what does it do? It cuts them in half, yes? So those two angles are the what? Same, yes? So this is equal to, so we're saying 11x plus 23 is equal to what? Solve for x. So what do? We would get 3x plus equals, then from here we can equals, divide by 3, x equals 4. Now, do I have to plug it back into both of them to find the angles? Eight times 4 is, the measure of this one is 67 degrees, and the measure of this one is 67 degrees. Yes? We good with everything here? Yes? Awesome. I rushed through a lot of that last bit because I didn't want to run out of time. Okay? So any questions on any of this here? So there's another one I was going to do, but it's the same exact thing, and if y'all are getting it, yes? No one's lying to me? It won't be the first time. Probably won't be the last. But that's all we're going to do.